All right, grade 12s, we're on day 8, solving right triangles again. So this is review. We're going to keep it really short on the off chance that you have a quiz tomorrow on related rates and the cast rule. So let's just go over right angle triangles again. So for right angle triangles, we have two tools, SOHCAHTOA and Pythagorean theorem. For right angle triangle using SOHCAHTOA, we need to use an angle of reference to determine which side is our hypotenuse, which is opposite, and which is the adjacent side. So if this is my particular angle of reference, my hypotenuse side is always the longest side. The side that is as far away from possible to the reference angle is the opposite side, and the adjacent side. It is worth your time to always label those sides. So the hypotenuse, adjacent, and opposite sides. Sine theta, cos theta, and tan theta are the ratios that we're referring to in SOHCAHTOA, where your sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. We can use these trig ratios to solve, which means to find lengths or angles or all of the above in right angle triangles. Here we have a triangle that has 3 and 5, and we are asked to find, or to solve rather, which means find everything. So let's label the sides. Let's call them J, M, B. And we want to find everything. So let's list it. We want to find angle J, angle M, angle B, and we want to find the 3 sides. By convention, we would call the side opposite to angle B. Since trigonometry is all about opposites, this would be little b, this would be little m, and this would be little j. So we want to find those 3 pieces of information as well. Should have done that in the same order. Anyways, we have 3 and 5 and 90 degrees. So little m, little b, and 90 degrees. So you can't find other pieces of information unless you are given 3. So we are an angle and 2 sides. So we want to find the other 3. Let's start with Pythagorean theorem and find side J. Pythagorean theorem would be a squared plus b squared equals c squared. So for this particular problem, we have 3 squared plus j squared equals 5 squared. So 9 plus j squared equals 25. I'm going to subtract 9 from both sides. It's 16. J would be length of 4. And we know a 3, 4, 5 triangle makes sense in right angle triangles. So we have length J figured out. We want to find the angles by using SOHCAHTOA. I've decided I would like to find angle B first. So that's going to be my angle of reference. That will allow me to label the sides, opposite, adjacent, and hypotenuse. I always start with the hypotenuse side. It's the longest, across from the right angle. The opposite side is across, far away, across the triangle as you can go. There's the opposite, and the remaining side is the adjacent side. I would like to find angle B, and it does not matter which trig ratio I use since I now have all 3 sides. However, I found side J, and it is possible I made a mistake. So I'm going to go with the 2 given sides, which are opposite and hypotenuse. I'm going to use the sine ratio then. Sine of angle B is opposite over hypotenuse, 3 over 5. To find angle B, I'm going to do second function sine of 3/5, and I will determine an angle for B of about 37 degrees. We are allowed to be lazy for the last angle. We know that 3 angles of a triangle add up to 180 degrees. So if I take my 180, subtract the 90 that we already knew, and subtract the 37 that we just found, we will find the remaining angle, which would be 53 degrees, approximately, because I rounded 53 degrees. We've solved the triangle using right angle trig. Isn't it nice to do something you're so familiar with? Page 12, 1 to 3, and a review handout.